Hello, my name is Warren Sims, and today I will be discussing Case Study C, Buried Treasure, from A Pragmatic Introduction to Signal Processing by Tom O'Haver. Now let's begin. Now you must excuse me if I'm a little sluggish because I'm new to this Zoom program, but I believe I'm getting the hang of it. Okay, now to the case study, Buried Treasure. Basically, this entire case study surrounds around the use of functions and commands to evaluate and clean up your data, to view the data in sections graphically, and to eliminate noise. Now, if one looks at this graph right here, it's easy to see that there's a flat baseline, what one would believe at first. But when analyzed using the function iSignal, it is seen that this flat baseline is actually composed of many bell-shaped peaks within itself. This is due to the fact that these amplitudes of these spikes are so much higher than these smaller amplitudes that when it graphs your data to fit it into the screen, it compresses it down and makes it where it's not even seen. But it is still very important to take into consideration. Now this function iSignal also, in addition to allowing you to see these little sections, smooths out the function and eliminates negative spikes using a median filter. Now you may be wondering, what is a median filter? Well, a median filter is a nonlinear digital filtering technique often used to remove noise from an image or signal. Such noise reduction is a typical pre-processing step to improve the results of later processing. Basically, it just cleans up your data. It allows for a smoother curve, which allows for easier calculations and more accurate calculations later on. Now to see iSignal in action. So I've already input some data in, data matrix 2, data matrix 3, and data matrix M, which is actually a source of data from Dr. Pardue, one of my instructors, containing some data from a collection called Cat and Mouse. So we'll take a look at that later. So if I use iSignal to evaluate data matrix 2, which has a few little minute errors here, but it allows you to view it in greater detail and it smooths the curves out and everything. In this case, there did not need to be any baseline correction, but in a different set of data, that would probably be the case that you would have to do some baseline corrections. So after evaluating that, I'll hop back over to my PDF and we'll take a look at some other pieces of this case study. Another thing that iSignal did was it looked at a slew rate limit, which basically means that when these points were plotted, it kind of stair-stepped. It kind of kicked up between. So this just smooths that out even more and allows for a cleaner graph to look at. Now if we scroll on down a little bit, another function used was iPeaks, which is known in MATLAB as peak fit or IPF. Now initially I thought these were two separate things, so I ended up copying over both sets of data. And the reason why I'm not running this in Octave is the fact that these codes were so massive that Octave says the file type is too large and exceeds the space limit, so I was unable to establish these functions in Octave. So that's why I'm running this whole show out of MATLAB. Well, going back, you can see why these functions were so massive. I mean, it's just insane how large they are. That's the iSignal function. And over here we have the IPF function. Just massive, massive. And there's the iPeak function. Massive, massive functions. So if we hop over to MATLAB to take a look at iPeak of data matrix 2, this is where it got really cool. This is where I got excited. This allows you to evaluate sections of your data. From the bottom, you can see your entire graph. But on your top, you see the singled out section, which is denoted by the little red dashed lines. It shows you your boxed off, and your green line shows where you're centered. This allows you to move across your data and evaluate specific sections, and even zoom in to evaluate them in more detail, all the way down to where it's just little points, and zoom all the way back out to see the collection that they make. And there's also various other things you can do with this. You can further smooth out the function. You can, I mean, it's really amazing. I haven't got to explore it as much as I would have liked. Now, if we hop off of that and head back over to our PDF, we'll talk a little bit more about some of these capabilities of these functions. Now, as you saw with that, you can break it up. You can zoom all the way in to where it shows the points themselves, or you can zoom out to where it shows a smooth flow of the values. Now, not only did I evaluate this data, I also evaluated the data from the cat and mouse game. So let's take a look at it. Now this was data obtained from Dr. Pardue, like I spoke earlier. And when it's analyzed in its small point form there, and you've got the graph here, I just think it's really neat to take a look at the material like this. And I know there's many uses of this that I can't even fathom at the moment, and it's just truly amazing the dedication it must have taken to write out these functions. So I'm going to hop back over here real quick, and one piece that I'd like to take a look at in the future would be the harmonic analysis of the Doppler effect, which is case study F. It involved the combination of sound and MATLAB. Like you could analyze sound using MATLAB and then generate sound using MATLAB, and I just think that that's a really cool combination. So I believe I've pretty well wrapped things up here. I would like to thank you for watching, and have a good day. Goodbye.